Hey guys, welcome back to my series on where I go through and solve the challenges in my book, The C Sharp Player's Guide. I've been going through these. I started going through them in order. Starting with the first one, working down. I don't remember exactly how far we got, but somewhere in this area. And then I started to say, let's jump ahead and get to the boss battle. So for the most part, I have skipped ahead and I've been doing the boss battles. I've recorded several videos that have not actually been released yet, so I don't know exactly where things are at, but I do know that the other videos I've been releasing every Saturday are uh, in this part right here, the Fountain of Objects. So I had a request to do the come back a little bit and do this Vin Fletcher's Arrows one. This is the first one where we're finally getting to classes. And I thought, you know what? I can do a short little bonus video and jump back and get these that somebody made a specific request for. Especially since I happen to have a little bit of extra time right now. So it seems like a good thing to do. So I'm going to do this, and then maybe I'll also get these other ones in here that are these four right here form a little series that kind of build on each other. So maybe I'll get through all of those. But yeah, this is the place where we're first starting to use classes, and it'll be fun to see where that goes. So I'm going to jump in here. This is the Vin Fletcher's Arrows one. Let's see. I can zoom in just a little bit more here. So we've got a guy who wants us to make an arrow class for him. Each arrow there's like three elements to it. There's the arrowhead that's made, it has different like material types and different costs. There's the fletching at the back of the arrow that has different types as well. And then there's the shaft that, like, it depends on the length. And we want to create an arrow class that represents one of these arrows with the arrowhead type, the fletching type, and the length. And then we want to allow a user to like go and like type in what they want for each of those things, and then have a get cost method. Now, one thing I will say on this challenge is this is pretty similar to like the score class that the book keeps revisiting. Uh, and and so you can see the constructor here, but even earlier here there was a a constructor, and here's a method. So we're going to end up building something very similar to this, only it won't be to represent a score, it'll be to represent an arrow. But this is a good sort of template that we can use to start building this. So I'm going to scoot this I'm going to keep this up, but I'm going to scoot it to the side on my second monitor that isn't being recorded. So you guys won't be able to see it, but I'll be able to refer back to it. But if you're watching this, you probably have a copy of the book yourself and can just do that yourself. All right, so I'm going to make a new project here. I'm using this console app one, not the .NET Framework one. And I'm going to say, hopefully that's not taken. It wouldn't surprise me if it is. We will see. For a very small project, I like keeping the solution of project in the same directory. You do not need to do that. And I'm going to choose my framework. I've got these three installed, but I want .NET 6. That's the latest and greatest. I'm going to create this. Give it a second. Open it up on my other window. Just a little bigger. All right. So let's think that, well, I could probably do that there for a second. Don't need to comment though. So define a new arrow class. So we're going to do I just lost I scrolled too far. All right. We're just going to do class arrow. And normally we name a class the thing it represents. Picking names is not easy. It's I mean, it's easy to pick a name, but picking a good name is not as easy as you might think sometimes. But as we're spending the time to get it right, of course, in this case, the challenge specifically says create an arrow class, so we know what it's going to be called. and with fields for arrowhead type, fletching type, and length. So we could do something like, string, we're supposed to do public string, arrowhead type, public string, fletching type, and public, let's say float length. That is a way to do it. However, this says hint. Arrowhead types and fletching types might be good enumerations, and I totally agree with that. So we have made the beginning of this class here, and I'm going to, but I'm going to use that hint. I like it a lot, and I'm going to make a, I just want to check something really quick. I keep wanting to type public. Yeah, we haven't talked about, I don't think we've talked about accessibility levels yet at this point in the book, so I'm going to leave it off. We'll just do enum arrowhead, capitalize that, but I think arrowhead is one word. Arrowhead type, and then let's name our types here. Let's see. We can have steel, wood, and obsidian. And then also another enumeration for fletching type, which is plastic, turkey feather, turkey feathers, feather. I don't know if that should be plural or singular. And then goose, feather, whatever it is, we should keep them consistent with each other. Goose feather, fletching type. All right. So I'm going to replace that here. Instead of a string. Now, before we get too far into this, I do want to call out the naming convention here. As you'll see in like the very next level, in I think this is level 19, in level 20 or whatever the next one is, as a general rule, fields should not be have this public on it, and for reasons that are explained later. However, the general rule is public things actually should be capitalized and not an underscore. And the book's description of that kind of actually doesn't describe it well enough, I think. So there's a lot of like, even though I did, so basically the book kind of makes it seem like your fields should always start with an underscore and a lowercase letter. I think the truth is more along the lines of things that aren't public but are private, which we don't have all the tools yet to really use that, but private things should be underscore, lower camel case, and things like this that are public should actually be not an underscore and should start with a capital letter. So I think I'm going to leave this the way it is for the moment. And a lot of that's just because we just don't have all the tools yet, but there is an argument. Maybe I'll change it for fun. No, I'm debating in my brain right now. You can probably tell whether to do these like this or like the underscore or lowercase. Like I said, we're in the problem in my mind is that we're in a scenario where we're kind of stuck between two worlds, and the book's got a bunch of examples one way, and I don't want to make it too complicated. So let's just keep these like this for now. That's at least consistent with the point, or sorry, is a score, the score class that was in the book. But if you want to name those capital and no underscore, you would not be wrong to do that. Okay, so we probably want a constructor for this guy, so let's do that. And that's just like it's like making a method, only there's no return type. And the name here has to match this. That's how we get a constructor. Then we Well, we either want to pass in all the data for the arrow, or we want to pick some defaults. Maybe we can do both. So what we can do is pass in the arrowhead type and the fletching type and the length, and then just assign all those here. It's nice that it suggested all of those. Okay. And then this, okay. So now we can create an arrow using this constructor by giving it the arrowhead type. So basically giving it all the data it needs so that it's in a happy state when the arrow comes into existence. We could also have a parameter-less constructor, one with no parameters like this. And we could say, well, like what are some good defaults? And in truth here, I don't know if like I don't know that there's a reason that we should default to steel over wood or over obsidian, or a reason to default to plastic over turkey feather or goose feather. Like I'm not seeing a compelling reason that we should just say, you know what, the most simple, obvious answer is we just create an arrow like this. So maybe that's a compelling reason to not have this second constructor, but I think it's worth illustrating here that we could have multiple constructors. The challenge doesn't demand it, but I'm going to do it anyway. And we could do something like arrowhead type is, I mean, maybe steel is the right choice. And the fletching type, let's make this be goose feather. And the length, uh, there was a time when I had Googled this recently and I knew what a good length for one of these was. And at this point, I no longer remember what a good, reasonable arrow length actually would be. So I could Google it again, but I'm going to not do that. I'm going to look up something within the book here really quick from a future challenge. All right. So, all right. All right, so I have elsewhere in the book, and maybe we'll get to it. It's in the Arrow Factories Challenge. There's 3 different arrows with specific lengths to make, and 65 centimeters, 75, 95. So we could put that in here, and the question here is this length? So it says like 95 centimeters, 75 centimeters. Is this length centimeters, or is it meters? Like if I let's say I want to do a 75 centimeter one here, do I do that? In which case this is and we probably want to make a comment. Put a comment in here so we don't forget. Or should I do this in meters and do that and then change this to that? Ultimately, I really don't think it matters. I think you can go either way. I mean, heck, you could put this in inches or feet, or you could measure it in furlongs if you wanted to. Um, I don't know that it matters, but maybe given the context, maybe we leave it in centimeters and do it that way. So the important thing to remember is that it's in centimeters. Okay. Like I said, we could do it. And by the way, I mean, the book specifically says make a field that's for the length. If I like, it's not uncommon for, well, a couple of things for people to do something like that, to attach the units to something like this where it could be confusing. And that, like, now is very clear. Every time you see that in code, you're dealing with centimeters. I've seen people do that. I'm not gonna do that here, but that's not a bad thing to do. And this is a much deeper conversation I'm not gonna get into too much, but sometimes people will make like instead of a float, they'll make like a separate class that just kind of is a wrapper around a float that is like a length class or like a length in centimeters class or something like that. And then your type itself calls out, like it's a lot more clear from the type. It's not just a float. I'm not going to do that here either. We're just gonna we'll be happy here, I think, with just saying we're just gonna say it's in centimeters. So that means if we want a default arrow, steel goose feather 75 centimeters, that's the way to do it. All right, so now we have two different ways we could create an arrow, and we could come here and we could say something like new arrow. Well, let's make a variable to store this in. So we've got an arrow here. And so we've got a variable whose type is arrow, and then we create a new arrow and store it in there. This one, doing this, will call this second constructor right here, and it'll give us a 75 centimeter steel feather fletching steel arrowhead arrow. And, or we could do this, we could say, oops, arrow 2 is new arrow equals new arrow, and then pass in the specific things we want. So we want an obsidian arrowhead, and we want fletching, plastic fletching, and then we want, and again, we have to remember here, this length is centimeters. So if we wanted to do it, 72 centimeter, that. Yeah. So, I mean, here we've got two different arrows that we've created. Each of them stored in different variables. And that's a good start. There's a couple other things that we were expected to do here. Let me get back to where I was a minute ago. This challenge. All right, so this asks us to, oh, okay. Before we walk away from the constructors, the book does show that we can have one constructor like build on and like call another one, and you can't just come in here and like call that like a method. Like here, it's like you can't call that. Non-invocable member arrow cannot be used like a method. So you can't just like call this, but if you do want to use it, I mean, we've done a whole bunch of like this code and this code is very similar. If we want to just simplify it, we could just, the way to say have a constructor call another one right at the start, not base this, and just pass in the parameters for this. So in this case, we can put this and this and this. And now when this constructor gets called, it will immediately call this constructor. It's just like calling a method, only constructors are, for most aspects, constructors are like a method, but you can't just call them normally. You can only call them when you're creating a new thing. And this is the way to call that constructor. Call this constructor when this one runs. So now this is just going to call this one with specific values, which will then set them all and then return, and then it'll run this code, which is there's nothing here. I'm actually going to shorten that even further like that. So, yeah. Again, I'm debating whether this even has a lot of value, just because the probability, like if 95% of the time what we wanted was a steel goose feather 75 centimeter arrow, yeah, we should do this. I don't think that's necessarily the case here, so we could just demand that users of this class, which is us here, people who are doing, going to use the class, always specify all these things. If they're always going to be different, it maybe makes sense to not have that. But anyway, enough about that. Let's move on. You do not need to have this. You only need to have this for this challenge. The last thing here is it says we need, well, there's two other things I'm going to add in this method. Add a get cost method. So public float get cost, that returns its cost as a float based on the numbers above and uses to display the arrow's cost. So let's do this. So float cost, we'll start at a 0, and then we'll say cost plus equals, so that we had to add a cost for the length and the arrowhead type and the fletching type. So we need to add in the length. Honestly, the length of the arrow is probably the easiest. It's 0.05 gold per centimeter. So 0.05 times length, which is in centimeters. We're gonna need to do that as a float. I don't know if hopefully by this point that type of thing is starting to get more comfortable to you, more familiar. But it's just to kind of illustrate that, like our cost that we're gonna add to is a float. This length is a float. This right here though is a double literal. And so when you do this multiplication with a double and a float, it automatically promotes the float, which is smaller, to a double, and it'll do this multiplication with two doubles. So it converts this float to a double, and now the result of this is a double, and it's saying, look, I can add floats and doubles, but and they don't match. Types matter in C#, so at some point we gotta just cast this back to a float. We could cast it to a float, or alternatively, if we just started this as a float, that solves the problem too. All right, so we do need to add in the arrowhead and the fletching costs, which are specific things. So this says for arrowhead, steel is 10, gold, wood is 3, obsidian is 5. So somehow we got to get that in here, and I'm going to use a switch for that. Given an enumeration, like enumerations and switches very often go together. So I'm going to use, well, I'll keep this simple for the moment. Let's see, arrowhead cost equals, and we'll do switch arrowhead type switch. And now we put in our thing. So if it's arrowhead type dot, let's see, steel is 10, wood is 3, and obsidian is, hey, how did it know that? This AI for like coming up with this is it's sometimes really surprising, and sometimes it suggests really stupid things too. So you guys got to be careful, but I'm surprised that it came to that conclusion. Given the things around here that it said, well, maybe it's 5. Maybe you guys in the videos can comment if you do something similar. I would be super curious to know if it also suggested 5 for you, or if this is somehow, um, or if this is somehow, if there's somehow it's smart enough to say the next obvious choice after 10 and 3 is obviously 5, or if it's like learned from something I've done in the past that it somehow has associated obsidian in my code with 5. I feel like that's more either that, or it's just like a kind of a random thing that it's like, hey, here's a number that's kind of like 3 and 10, but isn't 3 or 10. Okay. So now we compute the arrowhead cost, which is the simple switch, and then we'll do cost plus equals arrowhead cost. So now we've accounted for the arrowhead cost. However, even with this, I'm going to clean this up a little bit. Rather than putting that in a separate variable, which is fine, I'm just gonna combine this and this together and just say cost plus equals that. So rather than having a separate variable, we'll just append it to, we'll just increment, add it to this cost. And then we can do a similar thing for the fletching type. And we'll do See, even here, that 10 is the right number. But I wonder if it's getting 10 from that or if it's getting, 10 from there or... So, let's see. Fletching type. What else is there? Turkey. Okay. I feel a little better about this. Turkey feather. I'm not surprised it's suggesting this. But 3 is not right. Turkey feather is 5. So it makes me feel better that it isn't somehow reading my mind. Let's see. And goose feather is 3. Okay. So this expression from here to here will return a value that is one of these numbers depending on whatever the input was. Same here. And then whatever that result is, it will add that to the cost. You could make these separate methods. I don't like this means there's kind of a lot going on here, but I think I'm okay with it. Let's talk about this. This is saying the switch expression does not handle some values of its input type. It's not exhaustive, involving an unnamed enum value. For example, the pattern Arrowhead casting the literal int 3 to Arrowhead type is not covered. If we only use these options, then we should be totally safe with this, despite what the compiler is warning us about. However, it isn't unreasonable to account for that somehow. But the real question at this point is, okay, so let's suppose we do get something weird like that. Then what? And the answer here, so we could put in this default case, and the answer is I don't know what we should do here. This is throwing an exception, which is perhaps an okay thing to do. I don't know about a not implemented exception, but we haven't learned about exceptions yet, so I don't want to do that right now. Another choice is we could just pick a value. We could say it's 0. Except for then that means that somebody technically could do what that thing was saying and do like if we have somehow inadvertently used a value that we weren't expecting, this kind of hides it because now it's just returning 0. And yeah, so that's not ideal either. Hang on. I feel like I didn't explain it very well. This if we use plastic turkey or goose feather, we should be fine. If we abuse the system and do something like new arrow and then like that thing said, we just cast some random number to this. If we do something like that, that's always a dangerous thing to do, and you should only do it if you must. This will, like, the computer is going to keep running, even though that isn't one of our enumeration options. But that is the scenario. That is the only scenario where we would ever get to this right here. And like I said, the concern I have with just saying, well, if we didn't find a specific value, we'll just return 0, is in a lot of ways it would be nice to catch that early rather than letting that just keep going through the system. And with this being 0, like we're going to eventually ask for. In fact, we could probably do that here. Console.writeLine arrow 3 dot get cost. We could do that here, and like it won't even account for, like, we won't even necessarily realize that we've somehow evaded any sort of computation for the fletching type. In that sense, I would almost rather not put this in here, knowing that we haven't actually handled that. we haven't handled it well. And now, in this case, if we do this, it's actually our program's gonna crash on us. Crashing's not a good thing, but sometimes crashing is better than running with very definitely bad data, because that could lead to other problems down the line. And if it'll just crash here, then it gives us like realistically, the time we should be ensuring that we have a legitimate value is at this point, not necessarily down in here. Throwing an exception would be fine too. And like I said, sometimes there is a reasonable default. In this case, I don't know that there is. So anyway, trade-offs and a lot of options that you could do. None of like if you want to do, if it's anything else, just return 0. I don't like that's not bad. Like I said, there's trade-offs there. It gets rid of the compiler warning. I do like that part of it. But yeah, so I'm gonna not do that for now. I'm gonna just leave those warnings in there for the moment. And like I said, I almost think that like what this suggested here is a better solution, is to say throw an exception. But like I said, we don't have that tool available to us yet. So you could do that. You could leave it just like that. But for what we're doing right now, the outcome is going to be basically identical if we don't do that, because it will throw an exception. It'll just be a slightly different one. Okay. So we've implemented the get cost thing. And the one thing that we have left to do at this point is perhaps the more, there's gonna be a lot of lines of code here, but it's not anything we haven't done before. And that is that we're not supposed to just be creating new arrows. Totally can, but we're not supposed to be creating new arrows. We're supposed to be creating an arrow based on asking the user for this data. So what? I'm trying to think how to phrase this. What were my... So hopefully that part is not that weird or surprising to you. I need to store that in a variable. And now I need to convert this to an enumeration type. So I got that backwards. So in this case, if it's a 1, then we want it, the result should be steel. If it's a 2, then it should be wood. If it's a 3, it should be obsidian. Now this is the tricky part, because this, like, it was probably reasonable down here to say, look, there's only 3 good types. Up here, where we're dealing with human input, we have no clue what they're going to type. They might type A. They might type 72. So like at this point, this is the place where it matters a lot more to make sure that we have a legitimate type here. So we're gonna pretend the human is reasonable, which is not a safe assumption, but for the moment, let's assume. And yeah, so we're we'll just assume that for a second. But so now at this point we've got the arrowhead type, and you know what I can do here? We can put this all into a method. I'm gonna just come down here and just say method that returns an arrowhead type. Get arrowhead type. We're just gonna scoot all of this down into here. And then we're gonna have that. And then this will, so I could come down here and just say return arrowhead type. I was suggesting it a second ago. But the other thing I can do is I could just do it all. Return whatever the result of that is. All right. And now I can do a similar thing for the fletching type. Let's see, what were these? One is plastic. Two was turkey feathers, and three was goose feathers. Okay. And the last thing we need, so we could do that. And the last method we can do here, and these don't have to be methods, but there's enough there that if we did squish all of them together, it'd be pretty big. This one's going to be the simplest of them all. So pick a length. So we've been using two int 32, but I'm gonna do single, which is the version for a float. Now, yeah, okay. And then get the length. And now finally we got all the pieces from the user, and we can say we can make the arrow equals new arrow and pass in all this other stuff, arrowhead type, fletching type, length. And now we can say console.line arrow dot get cost. Let's do this. This arrow costs that. Okay. Hey, this is the first time we ran this. Now we'll run this and we will see what this does. Sure is thinking hard. All right. Well, first thing is, guys, it's got a hello world in there. We do not need that. So let's fix that. Pick an arrowhead type. So let's say 2. fletching type 3, and a length. Let's do 100. This arrow costs 11 gold. Is that right? So wood is 3. Fletching. What do we pick? Goose feathers. So that's another 3. So that's 6. And then the length is 0.05 times 100. So that should be 5. That's another 5. That is correct. I think we've implemented it correctly. Like I said, the one thing we haven't handled here is like checking input very well, because if I just tell this to run again, my hello world's gone now. If I say, oh, it's 66, boom, it blew up. So I mean, again, we could handle this with something like, look, if you're not going to give me good data, then I'm just going to pick it for you. Right? Like, could do something like that. Oh, I need a comma right here. I will say that some people in this kind of situation, some people will always just put a trailing comma on all of them. In C Sharp, most people don't do that just anywhere and everywhere, a trailing comma. There are other languages out there where that's a very typical thing to do. So I'm gonna not do that. But like I said, the nice thing about it is if you do have the comma and then you say, I'm gonna duplicate this line with Control D, like it all still it all still compiles, other than I've got the same thing here. But like I don't have to mess with it. So some people will do that. So anyway, that is a possibility here. That we could just pick it for them. If you don't have good data, then that's your fault. I'm not like, that's not a horrible way to handle this. Other than the user isn't necessarily going to know that it got chosen for them. So another possibility is to just do, check this another way. So something like, if option is greater than or equal to 1 and option is less than or equal to 3, which is our sum total of choices here, then we can do return that. And otherwise we got to handle it. So what we can do is we can just say, until indentation, right? All right. Yeah, so okay, so we could do that. That's a lot of code here, but so we're gonna loop until we leave the loop by picking a valid option here. And yeah, so until we have a valid option, we're gonna say, hey user, pick something, and then if we're in the right range, then we're gonna we'll actually return a correct value, which will leave the loop and the method, and otherwise we'll just keep going. So at this point, this warning can't actually happen, because this is an integer, and either it will be 1, 2, 3, or it will be something that isn't one of these, and we will skip past the loop and or skip past the if and come back up here. So at this point, this warning is actually something we can't ignore, and there is a way to say we could do that. I kind of hate that. That in particular is super, super ugly. But anyway, I'm not going to worry about that right now. But so this is a way that we could do it. And we could do a similar check on here, and we could do a similar check here to make sure that, because we didn't bother checking that at all. Yeah, honestly, I think you spend much time dealing with humans, and you will come to realize that one of the trickiest parts of programming is making sure that humans don't manage to find a way to sneak intentionally or accidentally garbage data in. Like this code, if we could safely assume that the data coming in was valid, is way simpler than if we have to account for the fact that humans are they don't understand how to use the software sometimes, and sometimes they intentionally want to cause problems. They're griefers sometimes. So handling, and even here, like we actually haven't handled a scenario where what if somebody typed in A? This is still going to break on us. And there are tools that'll solve that. So I mean, some of the reasons for us to not handle all these humans doing stupid things stuff is that we don't have all of the tools yet. So there are other tools we can use to more better safely handle garbage input, but um, I mean, like we could do, we really, like in this case, it really isn't going to hurt anything to do. To add that in, but it'll and that's a given how ugly that whatever, to tell the compiler, hey, ignore that. Given how ugly that was, I like this a whole lot better. I kind of like having no warnings if I can help it. Um, but anyway, okay. So we could do that for the others. We could do that for here and for here. I'm going to not do it. Like I said, I'm going to just assume in general that humans are, there's no benefit to them getting it wrong, and they know what they're doing, even though that's not totally safe. But for now, for the short term, I think it's okay to just make that assumption. Like I said, some of these things like this, adding this if in here helps a lot too. We're basically done with this, other than there's a couple of other variations on this that I have some comments on. One of them is, I'm just going to wing this here really quick. One of them is sometimes people will say, well, forget the numbers. Let's get, let's just have them type in. I'm gonna leave this intact here because this is that if statement. I'm gonna come up here. So I've messed with this one a little bit. I'll mess with this one now. What they'll do is they'll do this. So there is a thing that is uh this. So, and there's a couple of options here. This one uses generics, which we don't know about. Not that it's that hard to figure out. I mean, I'll show that in a second, but we haven't seen this either. So no matter what we're doing here, we haven't seen this. But type of Arrowhead type, and then we give it the string. So console.read line. And then we can cast this to Arrowhead type. Well, okay, now I don't need any of this, because what this is going to do is this is going to say, okay, and I could break this up. I'm going to do this here, but simplify this just a tiny bit here. Because this is a thing that comes up a lot as well. How do I, like, I've got this enumeration. How do I convert text to an enumeration value? This is the way I tend to do it for reasons that we'll see in a second. But this type of thing, this enum.parse, is a second option. And I'm going to not do that. But this can return null. It's hard to, you have to, I forget exactly what it is, Control Z or Control X or something like that, and then hit enter, and then it'll return null. I'm gonna not do that, and this is, so this says, you can see that there, string question mark. This says it might be null. At this point, we haven't talked about null too much yet, so I'm gonna just ignore that and pretend we didn't see that. And yeah, so anyway, then this method here, it will take the type that we're trying to parse, and which again, like I said, I'm using this type of thing that I could be wrong, but I really don't think we've seen that. Maybe we have. And then the string that we want to parse, and then that returns object. So I have to cast that to an arrowhead type, and then so now I've got that. So now if I run this, so this is the part that we were looking for. Pick an arrow. Oh, I left the text still says that, but it's actually looking for me to type in text. So I can type in wood. And I think now that one's expecting numbers and this one's expecting numbers. Yeah, so in this case, it worked, and it actually, let me run that again so you can see that too. I type in obsidian, come over here, and you can see that it parsed obsidian. So that is, like, that's convenient. Like, it lets me, like, it's really easy to do that. And like, even if I went and added 17 more types, this code should generally work. The danger is just in how flexible it is. So if let me restart this, and now I don't know if it handles capitalization. Let's try that obsidian. It didn't. So requested value obsidian was not. There's more there than was not found. So it has to be capitalized correctly, and even it more extreme, like these ones that are like goose feather, would be another arrowhead type. Because everybody needs nukes, right? The world is just short on nukes, I guess. In case you didn't pick up on that sarcasm, it was sarcasm. Yeah, so like I say, it's totally inflexible here. Nuclear warhead. Like I must type it in exactly as it's written in the code. I can't put a space in it. So this parse is pretty limited, and it's tied exactly to how, like, whatever you did in the code. And so, for example, if like they wouldn't be able to enter nuke, like they wouldn't be able to put a space in there. If they don't capitalize it, it doesn't work. They must type it in exactly as the code is, which means like now your user interface is tied to choices you made in programming and also limitations of the language. And it's like, for example, this type of thing here, if we wanted to be able to support, not that there are hardly any console applications that support multiple languages, but suppose we did, like I can make this type of code work just fine with Spanish and French and German, just by saying, look, pick one for, and I don't know any of those languages, but to just have this text be in that will work just fine. Our code is written in code. It's got identifiers that tend to be, I mean, the language is English based. So, but yeah, so it doesn't matter what your code is written in. You can still support a different language if you wanted to, really easily with this type of approach. This type of approach doesn't give you that flexibility, but again, it's always these things. It's always trade-offs. So, take it for what it's worth. The other thing that I will say here, though, is sneaking in some generics. Like I said, that we're way. There's a chapter on generics. You'll get there. It's not time for it yet, but I think you can kind of understand what's going on here when I do this. You just put these in these little angle brackets, they're called. And then I don't actually, like, it knows the return type won't be object, so I can just do that. And yeah, so I put my type in there, then it knows that that's going to, like, it knows I'm going to return an arrowhead type, so everything is all fine. I don't have to do any casting. That is simpler, but again, builds on these advanced features, generics. So if you had the full arsenal of tools, I would go with this over the other version I just had in there. Again, like I said, this is convenient for certain types of things, but it really isn't like the gold standard, because it's just, I mean, this can still fail if somebody types in something garbage. It still fails. But anyway, so we could do that. We could have done that down here. Anyway, just some other thing. Like I said, the book doesn't really cover that, but maybe it will in a future version. I see a lot of people kind of get hung up on, well, how do I take human input and turn it into an enumeration? So we've talked. I mean, this is one way. I usually tend to prefer this type of option just because it does decouple the code from the human input. I feel less bad about this type of thing if it wasn't something that a human had to type in, but it was just text that, like, it was saved to a file or something like that. Like, in my mind, that makes more sense to use this type of thing. But anyway, either of those could work, and either flavors of parse could work. And yeah, so the other thing I wanted to say about this, again, kind of a tangent here, but it is that I see a lot of people who will, in order to, because I mean, this is your first real exposure to classes, and some of the stuff, up in here, this, like, get fletching type, get arrowhead type, like, some of the stuff is like this stuff you've done a fair bit of, and it's pretty comfortable. But there's an open question for a lot of new people, like, how exactly do I manage creating an instance of the arrow class and getting all this input from stuff? And again, it's one of those things where maybe the first example here shouldn't have been allow the user to pick it, but just make this thing and then go make 4 instances and just, maybe I'll do that in the next edition, because I kind of like that approach. But this edition, 4th and 5th edition, both say ask the user to get it. So, like I said, there's a lot of people, there's this open question of, well, how exactly, like, where do these methods live? And you can see, like, my solution here was to put them separate from the arrow class. But I do see people who will basically take this, and what they'll do is this. Let me just show you this, because I think a lot of people do this. They'll come down in here and they'll say, I'm going to add these methods right here, which seems not totally unreasonable. And then, yeah, I'm going to delete this constructor for the moment, and I'm going to delete that, and I'm going to delete this, and then I'm going to move this code into here, and then I'm going to say new arrow. And then here I'm going to say, well, even something like this. Let's see. All right, something like that. So you call the constructor, and then it calls, like, get arrowhead type, which goes to the console and gets input, which gets a value, and then it returns it. And then we come in here and we get this fletching type, and we, it's parsed a little differently, but we come in here, we get this, and then we return it. Or, yeah, and same with the length. And sometimes what people do here, instead of returning it, they just say, well, I already have access to that here. I'll just make this void. And now I'll just set my arrowhead type. And now I don't even have to do this. I can just say get arrowhead type. And get fletching type. And then I guess here, like what I would probably do is I would say something like fletching type equals that. And then if we got through that, then break. So now we're out of the loop. And that's void. And, you know, I mean, same thing here. This could be void, and we can just say length equals that. Again, it would probably be reasonable to check the bounds, but all right. So anyway, so we do that, and then we do that, and now we populate all of our data, and then we do console.writeLine. And when we run this program, it should behave exactly the same. I was afraid of that. Well, we can edit and continue here. So these are quite expensive. There we go. This arrow costs 10,000 gold. Okay. All right. So I guess I see a lot of people who will do that. This isn't necessarily wrong, but I do like it isn't the way that I would do it. And the reason why I would avoid this is the way we've set this up. I have no, like, I cannot use an arrow in any context except for exactly what it does here. Like the arrow, I call this constructor, and it must go to the console window to get its input. And it doesn't, and it can't, like, no matter what we do, it will, in all scenarios, display in the console window, here's the cost. So the way that this is set up, there's only one way that you can use it, and it's exactly what we've done here. So like there's zero flexibility in it. And to allow the arrow to just kind of be its own concept, and it isn't worried about how do I create one, like how do I figure out where, you know, the data for this comes from, or how do I, like, you know how the cost is being used in the rest of the program. Even, yeah, so the way that I had it a moment ago in that sense is a whole lot more flexible, because I could take that class and use it in a whole lot of other programs. Like I could use it in a program where you walk around and you pick up arrows, and the game generates arrows all over the place, and it just picks random values for the arrowhead type, the fletching type, and the length, and you just wander around, and there they are. You can pick them up, and so the arrow class is reusable in that program without any changes in the way that I had written it before. But it isn't reusable. Like this class as it stands now, I couldn't do that. So I try to separate the input, like the going to the console, from the class itself, unless the class is specifically for getting input. And in this case it isn't. So if we wanted to make another class that its job was to make arrows from the console window, then I think it makes sense to do that. But otherwise, I would prefer to separate it. I mean, you can even see that just how much more flexibility we get just by moving this out of here and putting it here. Even just by pulling that out. So now we have to, like, we get a lot more flexibility even with just that change, because even now, like, in order to create an arrow, we go to the console window, but here, like, I can make 3 arrows, and I can say So like I said, now I've got a different usage here where I can just make 3 arrows, and they won't immediately tell me exactly how much they cost, because that may, here I just want to know all the arrows I just picked up, how much they all cost. So like I said, I'm going to undo this and go back to where it was. Like I say, that this earlier version where the arrow isn't focused on inputs and outputs. In this case, we've got to keep going. Hopefully I can undo far enough. Yeah, so, okay, we're back. So yeah, in this case, I said, now this arrow class here, like, because all it does is it represents an arrow, and it has this logic here for computing the cost. Like it's self-contained, and it's able to do its one job really well. And like this arrow could be used in a whole lot of different ways and situations, just by separating out that input. So um I think that's probably way more than enough on this video. I thought this was going to be like a 10-minute video, and I think I'm over an hour. Yeah. But this is, I don't feel too bad about that. This is your first real exposure to making classes, and I don't think it hurts to have spent the time diving into some of those different variations and ideas and stuff. But yeah, like I say, in my mind, this is a better version than squishing all this console.read and write stuff into this class, because it frees up this arrow class to be, this no longer has to be used only in this scenario of get that data from the user and write it out. So okay, I think that's enough on this for now, though. I will stop it, and there's 3 other things that build on this, so I'll keep this code and we'll do those later. Yeah, that's the basic gist, making our first class, and then being able to create one based on input from the user, being able to call its methods. And that's about it. I will see you guys next time.